In this tutorial, we are going to create a simple line of domino. Let's take a look at the finished result so you know what you will be making. The object we have currently selected is a path curve, a line, that determines the placement of the dominoes. When we adjust it in edit mode, the dominoes follow. When I make the curve longer or shorter, the length of the line does unfortunately not adjust itself automatically. This is a limitation of Blender. The length of path curves is not available for us to use in our drivers. So, we need to adjust a length property instead to make it fit whatever shape we create. Except for the length, we have the start frame. This decides on what frame the falling starts. If we set it to 30 and press play, the falling starts on frame 30 and continues until all the bricks has fallen. This line of domino does not use any kind of simulation, so we can scrub through the timeline and see the animation, change the length, or the shape whenever we want, and the result is instantly reflected in the viewport. So that's it. Let's get started. We will start by creating a static line of dominoes where the falling has reached halfway through. I won't worry about animating it until later. First, let's create a single brick. Delete the camera and light and grab the default cube. Let's give it more of a brick shape. Change its dimensions to 0.25 along X and 1.1 along Y, and apply the scale. To make the brick easier to lean, we want the origin point to be along the bottom right edge. Select it, move cursor to selected, and set the origin to the 3D cursor. Reset the location so the brick is moved to the center of the scene. And now we automatically get a falling motion when we rotate it around Y. If we now add an array modifier, change the offset to constant instead, 1 along X, and increase the count to 10, we get a basic line of domino with a distance of 1 unit between each brick. As you can see, this is a section of domino where no bricks has fallen. Since we want to create a line of domino where the falling has reached halfway through, let's create the opposite as well, a section where every brick has fallen. Copy the line and move it 10 units along X so they don't overlap. Since the bricks that has fallen should be to the left when the falling motion goes from left to right, we will edit the original line and not the duplicate. Rotate it 74 degrees around Y, the angle I want the bricks to have after they have fallen. Since we rotated the actual object, the entire array gets rotated, not what we want. To make the bricks keep their location after they have been rotated, all we have to do is to apply the rotation. This is possible thanks to us using a constant offset in the array modifier. The size and shape of the object does not affect its position. We now have one section where every brick has fallen and one section when all of them are still standing. So let's create a transition between the two, the bricks that are currently falling. The more bricks you have that are in a falling motion, the more realistic it will look since the transition between the two states will be smoother. I will settle for 6 of them, since it is good enough in my eyes. Move the standing line 6 units along X to leave room for our 6 transition bricks, copy it, change the count from 10 to 6 in the array modifier, and place it in between the two sections. To make it possible for us to lean each brick a different amount, creating the transition from standing to fallen, we need to apply the array modifier. Now we can enter edit mode and start leaning them. I will go from right to left, starting with the brick with the smallest lean. When I grab a brick here in edit mode and try to rotate it, it rotates around its center, making it very hard to lean it correctly. To make it rotate the same way as our single brick did in object mode, we will use our 3D cursor. Select the bottom right vertex and move cursor to selected. Select the entire brick and set the rotation mode to be around the 3D cursor. And now if I rotate it, the brick leans. Make sure that it is leaning right on the brick in front of it. And now it is just a matter of repeating the same steps for the other 5 bricks. Select the bottom right vertex, move cursor to selected, select the entire brick and rotate it into place. Since I've picked only 6 bricks, there will be some tiny intersections to make the entire fall fit, but I don't think it will be noticeable. But if you think it is, just make the fall consist of more bricks. Finally, let's rename our 3 objects. Bricks fallen, bricks falling, and bricks standing. And now we have a line of falling dominoes as a static mesh. Great. So how are we going to animate these bricks? We are going to use the same principle as we first used for the digital clock. That is, to move objects and hide certain parts the user should not see to create a kind of illusion. This also means that this simple version of the domino won't have proper support for motion blur. Instead, we will save that for the advanced domino tutorial, since it is much harder to do. I will try to demonstrate the way this is going to work here in the viewport by shrinking the window and turning on the snapping. Let's also turn on display only render so we only see the bricks. If I now move an object, you can see that it snaps to even units in the viewport. So, what happens if I grab all three objects and move them? It looks like the bricks are falling. They aren't, but just like with every kind of animation, our brains are tricked. Similar but different images are interpreted as motion. Just like with the digital clock when we saw the beginning and end of the rows of digits, if I zoom out, the illusion is lost when the beginning and end of the line is visible, making it look like something moving back and forth instead of something falling. So, to animate the dominoes, we are going to move them one unit at a time, just like I do here, while keeping the start and the end of the line in the same location. Turn off only render and the snapping so we can get back to work. Similarly to how we controlled our digital clock, we are going to add an empty that holds a property with the current time and then use that to drive the falling of the bricks. So, move cursor to center, add an empty, and name it time. Add a custom property, and name it current time. Increase the range so it won't interfere, and click OK. Let's add a driver to the property that increases the value 1 unit every frame. We can do this directly without opening our driver window by writing #frame. The hashtag adds a driver, and what comes after the hashtag becomes the scripted expression. And now the value is increased 1 unit per frame. We can even change the expression again by simply clicking in the value field. The current expression is displayed so we can adjust it. However, frame is what we want, so just exit without changing it. Now let's use this current time value to drive the falling of the dominoes. We want to move this falling section along the line to create the illusion of falling. To make things a bit easier, let's move the origin point to the front of the object. Select the standing section, move cursor to selected, grab the falling part, and set the origin to the 3D cursor. Now the value of the X location directly reflects how far along the line it has moved. At a value of 0, it is completely outside the line. A value of 3 moves it 3 bricks inside, and a value of 8 moves it 8 bricks inside. So, let's make this movement automatic by adding a driver to this X location. This time we need to open the driver window since we have to add a variable. Add the current time as a variable, and name it time. If we set the expression to just time, the falling part moves when I scrub the timeline. Notice how it moves 1 whole unit at a time automatically. We don't need to add a floor function to get this behavior since the current frame is always a whole number. Let's set the start frame of the timeline to 0 so the falling starts completely outside and the end frame to something large so it won't interfere. The further along the animation we are, the fewer standing bricks should be ahead of the falling part and the more fallen bricks should be behind it. We are going to accomplish this by driving the count in their array modifiers so the standing and fallen bricks are always right in front and behind of the falling part. Let's focus on the fallen bricks first. We want to drive the count of the array modifier based on the current time, so we can copy the X location driver of the falling part to save time. Since the falling section is 6 bricks long, the fallen bricks should start appearing 6 units after. So we want the expression to be time minus 6. And now when I scrub the timeline, fallen bricks always appear right after the falling part. Let's do the same thing with the standing bricks. Since these bricks should disappear one by one, moving towards the end, we need the array modifier to go the opposite direction. So, change the constant offset of the array modifier to -1 instead, and move it 9 units along x so it doesn't overlap. And now when I decrease the count, it moves towards the end of the line like it should. Now we just need this to happen automatically, so paste our copy to driver as a start. Since the line currently has a total length of 26 bricks, 10 plus 6 plus 10, we want the count to be 26 minus the time. And now when I scrub the timeline, we have a working line of domino. Great. Right now, the user doesn't have much control. The length of the line is set in stone, and the animation always starts on frame 0. So, let's add a couple of custom properties so the user can change this. Since the posing of the line will eventually be done using a path curve, let's add one right away so we can add the custom properties to it, collecting all controls in one place. Move cursor to center, add a path curve, and rename it Domino. Now add a first custom property, length, and set the maximum to say 500. Since this will be the number of bricks in the line, it will have to be a whole number, so remove the decimals. Let's give it the same value as our line of domino currently has, 26. Now we just need to adjust our standing bricks driver to use this length value instead of the fixed value we gave it before. Add the length as a variable and change the 26 in the expression to length. And now we can adjust the length of the line by changing the length property. However, when I make it shorter, I get a gap between the standing bricks and the falling bricks. We need to move the standing section closer to the falling section when the line is shorter, since there are fewer bricks. We will do this by driving its X location. Copy the count driver and paste. Since the first brick starts on 0, we want this section to have a location of 1 less than the total number of bricks. So set the expression to length minus 1. Now we can adjust the length of the line and all sections will stick together. Let's add another custom property, start frame, so we can choose on what frame the falling starts. Set the range to something very large so it won't interfere. Let's also zero it, removing the decimals at the same time, since a frame has to be a whole number. This control should affect the current time property, making everything start earlier or later. So, add it as a variable to the current time driver and change the expression to frame minus start. Now a start value of say 20 will decrease the current time value by 20, delaying the falling by 20 frames. And now I can move the entire animation, making it start earlier or later. Great. Right now the domino looks great as long as the falling part is in the center, but whenever it reaches the beginning or the end, things starts overlapping and bricks go outside the line. It is clear that things are not restricted properly and that we see too much. I will split this into 2 parts, focusing on just making the beginning of the line work perfectly in this part before we move on to fix the ending in the next. First of all, since we use an array modifier for the line of fallen bricks, it can never go below a count of 1. There will always be at least 1 brick visible, even though there should be no fallen bricks in the beginning. So, we are going to give it a mask modifier and use that to hide the 1 brick left behind. Add a mask modifier and add a driver to the toggle. We can copy and paste the count driver to save time. The driver starts working correctly right away. This is because the driver already gives us the number of bricks that should be visible. When that value goes below 1, the mask modifier is toggled and the brick gets hidden. With that done, let's make the beginning look like a line of domino actually starting to fall. The current problem is that every brick in the falling part is always visible, The bricks that are outside of the line should be hidden and then start appearing as they move inside. To make this happen, we will add multiple mask modifiers that covers one brick each and then add drivers to them, making one brick appear at a time. To only have the modifiers affect one brick at a time, even though they are all part of the same object, we will use the vertex group setting we ignored before. If we create 6 vertex groups holding the vertices of one brick each, we can use them for targeted hiding and showing. Enter edit mode, add a new vertex group, and name it brick 1. Select the entire first brick and assign it to the vertex group. Create a new group for each brick and assign their vertices. Now we will add 6 mask modifiers. The fastest way to do this is to just add one modifier and then copy it 5 times. Then set each modifier to use a different vertex group. To make the bricks show and hide automatically, we can't use the toggle button anymore. This is because we have now selected a part of the mesh using a vertex group. When we make one brick visible, the rest of them will automatically become hidden, so we won't be able to show more than one brick at a time. To be able to turn on or off each brick individually, we will have to drive the visibility toggles of the modifiers instead. Since we want the modifiers to hide the vertices included in the vertex group and not the opposite, we need to activate the invert selection button for all of them. Let's start by adding a driver to the viewport visibility of the first modifier. We can copy the X location driver to get a quick start. The first brick should start appearing when the falling section reaches a position of 1, since it is then a part of the line. So when the time reaches 1, the mask should be deactivated, which gives us the expression 1 minus time. Now whenever the time becomes 1, the driver value becomes less than 1 and the brick gets visible. Creating the drivers for the rest of the bricks is very easy, since all of them should just be delayed one more unit each. Let's copy and paste the first driver and adjust the expression. For the second brick, the expression should be 2 minus time, since it should become visible after the time has reached 2. For the third brick, it should be 3 minus time, 4 minus time, 5 minus time, and 6 minus time. Since we are driving the visibility of the modifier, we will have to add identical drivers to the render toggles as well, so it looks the same if we were to render it. This can be done by simply copying and pasting the drivers from the viewport toggles. And now the brick starts to appear like they should when I drag along the timeline, making it look like a line starting to fall instead of a moving object. However, what does it look like before the falling animation starts? We can take a look by increasing the start frame property, making the falling start later. As you can see, the line gets longer the further away from the falling we get. This is because the number of standing bricks is directly driven by the time, so it just continues to grow. We clearly need to limit the count to the length of the line, so add a min function, length, to the expression. And now the line remains static until the start frame. At least to the naked eye. The location of the falling part is also directly driven by the time, making it continue moving away from the line. It doesn't matter since it becomes invisible whenever it goes outside the line, but I will give it a max 0 function anyway. And now the beginning of the line works perfectly. Great. With the beginning done, let's focus on the end. First of all, since the standing bricks uses an array modifier, there will always be at least one brick visible. So let's add a mask modifier to it so we can hide it when everything has fallen. Copy the count driver and paste it to the toggle. This works right away for the same reason as it did for the line of fallen bricks. The driver gives us the number of bricks that should be visible, and when it goes below 1, the mask modifier is toggled, hiding it. Now for the actual ending. When the current time goes beyond 26, the length of the line, the last bricks should just fall over and no new bricks should be added. However, right now, the domino just continues to grow forever without reaching an end. So, to fix this, can't we just hide the bricks of the falling part one by one to fade it out, like the opposite of what we did in the beginning? No, we can't, because the last brick should be lying flat on the ground. If we were to just fade out the falling part and end it with the line of fallen bricks, the final brick would be floating in the air, resting on nothing. We have to do something else. Before I show you what, let's first make sure that everything stops when we reach the end of the line. Right now, the falling part just continues to move forever. We need to stop it from ever getting a location bigger than the length of the line. So, add the length as a variable to its x location driver, and add a min function length to the expression. The fallen bricks should stop growing as well. The highest count it should be able to have is the length of the line minus 6, since the falling part consists of 6 bricks. So add the length as a variable, and add a min function length minus 6 to the expression. And now it stops at the end. So, with that done, we are ready to create the actual falling animation. The way we are going to do this is by using what I call replacing geometry, switching between different but similar objects to create the illusion of movement. I will create 2 additional copies of this falling part and modify them so we get 3 objects with different amounts of fallen, going from standing to lying flat. Then I will show them one at a time as if they were images of an animation, making it look like the bricks are falling. So, let's copy the falling part and move it along Y for now so we can see everything. Instead of having a copy of the X location driver, we can simply delete it and instead parent the new object to the original. Let's also delete all the modifiers, their drivers, and the vertex groups, so we get a clean object to work on. With that done, let's hide the original so we can focus. This object will be the middle part of the animation, the one that is right between standing and lying flat. Let's start with the final brick, so move the 3D cursor to its bottom right vertex. Rotate it so it is right between its current position and lying flat on the ground, and adjust the rest of the bricks to match this new angle. Then copy the object, move it along Y, and hide the old one. This will be the third and last, where everything is in the final position. Rotate the last brick so it lies flat on the ground, and then adjust the rest of the bricks. With that done, let's unhide everything. We now have the 3 pieces of movement that will create the ending animation. Let's drive their visibility so we only see one at a time. The first original object should be visible all the time until the end when it should be hidden. Then our 2 additional objects should take over to end the animation. To hide every brick in the original at the same time, we could go through every driver for all the mask modifiers and make them turn off after a certain value, but that won't be necessary. It is much easier to just add another mask modifier for the entire object in addition to the masks for the individual bricks. So, add a new mask modifier. For this to work, we need to add a vertex group that holds everything. Leaving the vertex group selection empty to select everything won't work anymore when we have vertices assigned to vertex groups. So, add a new vertex group, name it all, add all vertices to it, and select it as the vertex group in our new modifier. Now toggling the selection instantly shows or hides every brick without us having to worry about all the individual mask modifiers. So let's drive this toggle. Paste the driver we have already copied. We want it to be hidden after the falling part has reached the end, or in other terms, when the time is bigger than the length. So change the expression to time minus length. And now when the time is bigger than the length, the driver will get a value of 1 or more, and the object will be hidden. When the first falling part gets hidden, the second part should appear. Copy the driver we just created, add a mask modifier to the second part, and paste the driver. It is working by default since the selection is inverted compared to the original, selecting no bricks instead of all of them. So a value of 1 makes the object show instead of hide, making it become visible when the original gets hidden. However, we want it to disappear again in the next frame to make room for the third and final part. The easiest way to do this is to modify the curve. Duplicate the 0 keyframe and move it 2 units along X. Now it will only be visible when the driver value is 1, making it only show during a single frame. Let's give the final part a mask modifier as well, and paste the driver we copied earlier. This one is supposed to appear 1 unit later than the previous part, so just add -1 to the expression. And now our 3 parts show and hide like they should. Only one is visible at a time, and they go from the first to the last. All we have to do now is to move them back to the same location, and the ending will work. And now the line of Domino works perfectly from start to finish. Great. Now when the falling of the bricks is working, all that is left to do is to make them follow the path. First, select the path, enter edit mode, and adjust it so it covers the entire line of Domino. Then add a curve modifier to every brick object, and set it to use the domino curve. Remember to include the extra objects that creates the ending animation. You can either go to the end of the animation to make them visible in the viewport for selection, or you could just select them in the outliner. And now we can change the shape of the line by changing the shape of the path. Great! The functionality of our domino is now complete. All that is left is some small adjustments to make it more user-friendly. First of all, the length of the line should never be able to be less than 6, since that is the length of the falling part. It can't show anything shorter than that, so set the minimum value of the length property to 6. Let's also hide the empty that holds the hidden time property, and turn off the viewport selection for everything except the path curve. All changes to the curve should be made in edit mode, so to stop people from changing things in object mode, I will simply lock all its location, rotation, and scale properties. And that's it! This concludes the tutorial on creating a simple line of domino. I hope you have learned something. Thanks for watching.